Today on CodeDependent, we will be talking again about easing. This is the process by which you control the motion of objects or the animation of time during an animation. By default, you might have behavior where basically you move an object from here to there. You use linear easing, which means just as the animation happens, you move in time proportional to the elapsed time that's happened in the animation. But it's usually more interesting, especially when moving objects around on the screen, to move them in a more natural arc. So you might accelerate into the motion and decelerate out of it, which is actually the default ease that we have in the Flex SDK. So there was in Flex 3 one way of doing easing, which used easing classes that had functions, and you would pass in references to these easing functions into the Flex 3 effects. In Flex 4, we have a different approach where we actually have an interface called IEaser, and then you implement classes based on that interface, and then you pass in instances to the Flex 4 effect saying, this is the class that I want you to use for my easing behavior in this effect. And we have default easers, so you don't usually need to worry about it. We have standard easers that you can just sort of use, create instances of, and use on the fly. And so you'll get 98% of the way toward what you want. But if you want custom easing behavior, then it would be nice to know how to actually create one of these things. So that's what we'll take a look at now. So if we take a look at, first of all, the sample application that we have. It's a simple application. You click on the button, and the button moves from the left to the right. And this happens by basically toggling states, and then when there's a state toggle, we run a transition, and that runs the move effect that you see. So if we take a look at the code here, for this application, we have a couple of states declared, S1 and S2. We have a single transition declared in the transitions block. And the transition will kick in anytime there's a change between S1 and S2. And that transition has a move effect in it, which targets the button that you saw and allows for a duration of 1,500 milliseconds. That's an awfully long duration. The only reason it's that high is because I wanted you to be able to see something meaningful in the video. Otherwise, it would happen so quickly that you would kind of wonder what the big deal was. And then we have a button down here. Label says move me. We give it a position of 50, and then we give it an X position of 250 in S2. This is the new states declaration syntax for Flex 4, where we declare properties in line for each state. And then finally, we have a click command. I use this a lot in a lot of my demos where I basically want to toggle between states. So this says set the current state value based on what it currently is equal to either S1 or S2, and that'll simply switch between the two of the states. So what happens is you click on the button, it sets the opposite state, sets the other state to go into. We recognize internally that there's been a state change. We run the transition runs the effect, and the effect moves the button over time. So how do you actually change the easing behavior of this thing? By default, you could see that the button actually was not linearly moving, but actually moving in a more interesting way. It actually accelerates gently into some top speed and then decelerates out. By default, internally, we use a sine function. We ease into that and then ease out of it, so we get a bit more of a natural movement than simple linear easing. But let's say we wanted completely custom easing. What do we do? So let's go into our utilities package over here, and we'll create a new class. ActionScript class. We will call it custom easer. We will implement the interface IEaser, and we'll put it in the utilities package. It will spit out all this code for us. We've got a constructor there. And then we have this one function from the IEaser interface. This function is called ease. And it takes a fraction, which is a value between 0 and 1, and it returns a value usually between 0 and 1. And this is basically the elapsed fraction of the animation. So the value that you receive is the fraction elapsed of time that this animation is supposed to take. So if your duration of your effect is 2,000 milliseconds and you've been running for 1,000 milliseconds, then you'll get a value of 0.5 here. And then what you do in the function is you use whatever calculation you want to, and you return back a different or the same fraction representing your eased fraction of the animation. So for instance, right now by default it says I'm going to return 0 here. So we can go ahead and run our application and see what happens, and nothing happens because that was kind of a trick. So we haven't actually applied this easer yet. What we need to do is add that in as the easer for the effect that we have in this code. So first of all, let's go ahead and add a declaration section so that we can put the easer in here, and we'll say I want that custom easer object, and I'll give it an ID of my easer. And now we can come down here in our effect and we can say, okay, the easer for this effect will be that instance that we just created above, my easer. And we can run the application and we click on the button and nothing happens until the end of the state change. So we are running an effect for 1500 milliseconds, but nothing is happening. And the reason is, if we go back and look at the custom easing code again, it returns 0. So this basically says, I don't care what fraction you pass me between 0 and 1. So as the animation is going, that fraction is going from 0 to 1 over time, and we are always returning 0. And that 0 is used in the calculation of how much to move the x value over time. So we're constantly multiplying 0 times the delta that the button wants to move, and we're getting back basically the position it started from over the duration of the effect. And then at the end, we stop running the animation, and it hops to the value that it should have in state 2. So that's why it's not actually doing anything interesting. So let's start playing with the value here. If we return back the fraction that we get and go ahead and run the application again, now you'll see different behavior. You'll see a linear ease. So this is basically returning back the elapsed fraction of time. So in the event that you've run halfway through an animation of 2,000 milliseconds, we'll get a value of 0.5. And we'll return back a value of 0.5, which means there's no easing being applied at all. You're just getting linear movement, which can be totally adequate for some cases. Like fading, linear ease is fine. Moving things around on the screen, it tends to look sort of very artificial. You really want some sort of organic behavior there, easing in, easing out, whatever. Something to look better than this sort of jerky linear behavior that we have here. So let's do something a little different. What if we return 1 minus fraction? So again, recall that we're getting a value between 0 and 1, and now we're basically going to return a value between 1 and 0. So we're returning the opposite. So we're basically going to move the opposite direction and then snap back at the end as we actually apply the end state values. Not very interesting, but at least you start to get a sense for how this thing is actually affecting the animation results internally. We could return back some sort of exponential. Let's actually multiply the fraction times itself 3 times. So we're going to get basically a cubic function here. And we're going to ease into this thing. So basically, every value we get, we're going to multiply it times itself 3 times. You start at 0. You're going to be at 0 for quite a long time. We're basically going to give back smaller numbers than we get in. So we're going to take a long time to accelerate. And then finally, by the time we get to 1, we're going pretty fast to try to catch up to this thing. You could graph it over time. It would be a nice sort of exponential acceleration curve that we're getting here. It's basically accelerating all the way in this cubic curve motion. So we could go ahead and play with other values here, or even better, you could go and look at some of the existing classes that we have. So we have power, which represents the ability to do any sort of exponential function like this. We have linear, which is just like what we saw before, where we just return the fraction that we were given. And we have a couple other ones that just came online last week, actually, bounce and elastic. And you can go ahead and check out that code and sort of see how these things work internally, and then start playing with it on your own. In future episodes, we'll talk about other kinds of easing that we can do and how to write custom easers of your own to have different behavior. But in the meantime, go ahead and check out the application and play with the code and create some easing of your own. If you want to see the code for this application and other related applications, check out my blog at graphics-geek.blogspot.com.